Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to Data Skeptic Recommender Systems. There's a lot of discussion these days about social media. There's some important laws being passed in other countries and in places even here in the US. Now, you can come at this problem philosophically and have a bright idea and argue for it and debate, but the most interesting angle to me would be an empirical one. How do we measure the harm caused by social media? What is the null hypothesis, and how do we prove it false, if indeed it is false? Well, there's a lot of great scholarship on that, including a paper we're going to talk about today called AutoLike, Auditing Social Media Recommendations Through User Interactions. Social media is a black box. It's not open source. It's definitely not open data. So how can you study it from the outside? Well, AutoLike is one great example of how to do that. We'll get into that as the focus of our interview today.
My name is Hugh Lee. I am an academic researcher working at the intersection of privacy, automated systems, and applied machine learning to study data collection practices of platforms such as smart TVs and virtual reality devices, and also how to study these practices through improving privacy-enhancing technologies such as ad blockers. More recently, I have been interested in developing frameworks to examine recommendation systems that behave as For You pages, such as those in TikTok and YouTube Shorts. So the majority of this work was done during my dissertation work at the University of California, Irvine, and under the Proper Data NSF Frontier Project. I am currently bringing my expertise across these areas as a senior technologist at the Federal Trade Commission's Office of Technology. Just as a general disclaimer, I am participating in my personal capacity, not as a representative of the FTC, and the views expressed are my own and do not reflect those of the Commission.
And are you open to discussing a little bit about your role at the Commission? Obviously, you speak on your own terms. Maybe you want to leave it alone or just give people some understanding of the types of job opportunities that are out there.
So as a senior technologist at the FTC, I get to kind of apply my knowledge on technology, security, and privacy basically across a spectrum of regulatory actions that the FTC does. For example, I can work as part of case teams. I could help write memos so that the agency can understand better certain, emerging technologies. I can surface certain, important issues that the agency or commission may need to understand and to help them kind of like focus on those certain issues. And also, I think importantly, I get to be at the forefront of regulatory actions and to really see how perhaps academic work, research, findings can be applied for regulatory actions.
And would you say recommender systems are a focus of your work or just one piece of a larger puzzle?
I would say it's one piece of a larger puzzle. It's something definitely that I'm very interested in and it's very timely. And also as a personal capacity, I use social media a lot, especially TikTok. So I think it's really fun to kind of both use it and then also do research on it.
So we're definitely going to zoom in on the recommender system part when we discuss the paper AutoLike, Auditing Social Media Recommendations Through User Interactions. But before we jump right in, can you say something about then, the complement of your interests? What other areas do you spend time thinking about?
More recently, I am trying to, investigate and learn how academic research, particularly on, security and privacy, can kind of inform policymakers or regulators and vice versa. So I think it's important to understand, is it the methods or tools that are being useful, or is it particular findings? For example, do we need to always find, explicit harms to consumers or to minors and children for it to be helpful, that kind of thing, or perhaps maybe data sets.
Well, let's jump into AutoLike a little bit. For listeners who haven't taken a look at the paper yet, can you talk about the project and the framework and what you were going for with this project?
Yeah, so the project AutoLike focuses primarily on social media platforms that have recommendation systems that behave like For You pages. So this means that the user uses the app, they see one content like a short form video at a time, and the user can interact with the For You page, meaning they can bookmark, they can share. And then they can swipe up to see the next recommended content. And these particular platforms like TikTok, YouTube Shorts, Instagram Reels, and stuff are very, very popular, especially with kids and younger adults. And I think it's, as a user myself, it's very engaging as well. However, these recommendation systems are very opaque. You kind of don't know how they work and also what kind of content is being shown based on the interactions with it. And so we took a lot of inspiration from a lot of news that are, for example, from whistleblowers or from leaks or from actually other prior research and user studies as well, that these For You pages or recommendation systems can be harmful to users. And these are also kind of outlined in the platform's community guidelines as well. For example, they can list all the kind of problematic content that should not be on the platform, like mental health issues or dangerous challenges. So the problem is, well, how do you audit these recommendation systems in an automated way and efficiently? Meaning, like, for example, taking the view of a regulator who does not have a lot of resources. How can I audit the system quickly?
Well, today, I guess you could sign up for an account and you could use the system and you could have a very anecdotal experience. Maybe you could get a few friends to come over and see what their feeds look like. And then you have sort of a small, non-statistically significant sample with some selection bias to it. What does this look like from a proper scientific framework? How do we do a good sample and take a measurement?
Yeah, so what AutoLike is different from what you're mentioning is that it doesn't try to capture how real users would interact with the recommendation system. At a high level, the user of AutoLike can say, I want to drive the recommendation system from scratch to a particular topic of interest. For example, I only want it to serve me topics on pets. So what do I need to do? Do I need to like? Do I need to bookmark to get there quickly? And then we can see like how quickly can we get there and how much content will be served. And then you can also then evaluate or characterize the content that you get served. So in that particular perspective, it doesn't really need to, be directly reflecting how a user would use it.
It's almost as though you're really performing a search or a what-if scenario. Is it possible, or what does it take to get, let's say, puppy content? I bet that's an easy one to achieve. But what if I wanted obscure 17th century French novels? They're probably in there somewhere. There's a lot of content, but what does it take for me to find those? Is that effectively what the framework is doing?
Yeah, exactly. It's agnostic of the topic of interest. So in general, the user of AutoLike, this tool, can pick any topic and then go from there to figure out how you would go there. So I think a more simpler example would be, I want to see videos of cats. And along the way, in the beginning, they may show me popular videos of cats or dogs. And that's kind of close to cats. So then, you would intuitively like that kind of content and then keep going until maybe those switch to cats or something like that. You know what I mean? So there's like multiple steps that kind of content that can go through until you get to the particular topic of content that you want.
So that one's sort of obvious to me, that if I wanted kitten content, I think I could achieve that pretty quickly. If I wanted, let's say, some content about like self-harm or something like that, I would hope there really isn't much content like that on the platform, but it's also presumably harder to get to than kittens being cute. What is the strategy of the framework? How do you get from a brand new initialized state? Maybe you could talk about that too, because I know there's some interesting automation things going on here. What does it take to go out and search for the sensitive content you're wondering might be out there?
Yeah, so we formulate this problem as a reinforcement learning problem. So let me quickly explain that at a high level. So basically, from the beginning, the user of AutoLike will pick a topic of interest, right? For example, self-harm, it wanted that kind of topic. And the beginning state would be a fresh For You page. So basically, we would make a profile. You can actually go to the settings and say, I want my For You page to be completely refreshed, that you don't know nothing about me. The reinforcement learning has a particular smart agent that wants to maximize cumulative rewards over time. And it does that through trial and error by interacting with the environment. In this case, the environment is the TikTok For You page. The challenge is that the agent knows nothing about the environment, the TikTok, right? So it has to learn by trial and error. So that means that it's going to try liking, bookmarking, sharing, or skipping even. And then from those actions, it will get back a reward. And that reward, the higher the reward, it means that the better the action is. It means that, the content that's being served next would be closer to that topic of interest that we have chosen. The agent will keep learning that over and over until it will eventually learn the optimal action to take per state to get to what you want. That's kind of the overall strategy. So now relating back to TikTok, we represent a state of a TikTok by just like a score, like how far from 0 to 1, how far are you from this TikTok? Is like, for example, cats, is it very far from self-harm? If it is, then, it would be a low score. It's kind of like topic classification. It is cats related to self-harm. And if it's a low score, that would also be reflected to be a low reward. So that means that, okay, maybe we want to skip this particular cat content because it's not what we want.
And can you talk a little bit about how you label the content? I'm sure if it was pre-labeled as self-harm, it would be banned by the platform. So it's not obvious when something comes to you. How do you end up getting a label?
Implementation-wise, how does the system know what kind of content it is? Basically, what we do is we extract the TikTok URL by using the app's share feature. So for example, when you share to a particular person and you can copy the link, we get that link and then we send it to an external server that would open up the TikTok in a browser. It can then download that video, and then we can now extract certain information about that TikTok. For example, we can get the description and the creator of that TikTok. We can feed it through OpenAI's Whisper model, which takes the audio of the TikTok and turns it into text. So we concatenate the description and the audio to text, and we feed it through, for example, any kind of AI model that can do topic classification. So it's like, is this related to cats or self-harm? And then we say, give me a score between 0 to 1.
And then the agents themselves, I'm curious if you can elaborate on how intelligent they are. They can start from zero knowledge and just sort of randomly like or skip or take these actions. But it seems like it would be surprising or maybe inefficient to random walk from the initialized state into one of these undesirable states. Or maybe you're going to tell me it's actually rather easy. I don't know. What are the agents doing?
Yeah, so in the beginning, for this RL agent is not going to know anything. It's going to have to do some exploration. It doesn't know which action is good. But as it learns across several hundreds of thousands of TikTok videos, it's going to be like, okay, I'm at a particular topic of content that, for example, may be about mental health, but it's a positive, it's about awareness, but it's still about mental health and it's kind of related to self-harm. Then you would get a particular higher reward and then say, okay, now I know that liking this kind of content is going to be good. It will get me kind of closer to that end goal. So basically, how does it know? It takes the reward and averages kind of like over time. And it would know like, since I got a higher reward last time, I'm going to maybe keep doing that since I will continue to get the higher reward, or I may explore another random action that is kind of unknown, but may give me better rewards than what I already know. So there's this trade-off between always doing the action that you know versus exploring other actions that you do not know, but may have better rewards.
Well, it sounds like the approach is robust enough to really apply to any topic you wanted. But for the purposes of your study, what sort of topics were you focused on?
Our paper actually tries to look at both benign topics like sports, pets, weather, and also other topics like mental health or like more negative sentiment mental health. So what we first do is we do a control experiment across 100 videos. A control experiment means like we're going to just simply skip all 100 videos and see what kind of content we get. Now we're going to run AutoLike and say, oh, I want you to drive the recommendation system to serve me cats. And I'm going to like every time I get closer and closer across the same 100 videos. Or you can compare it to the control experiment and see that across 100 the videos, liking the videos will start having the recommendation system serve you, I think, like 2 times more pets and sports content versus just skipping any content.
Well, could we talk a little bit about some of the empirical results? Were the agents able to achieve their goals?
I thought, yes. So the experiment that I talked about is that we are able to drive the recommendation system to personalize, basically, or to start serving a lot more of the content that you want across pets, sports, weather. We also try to look at another dimension, which is sentiment. So basically like happy or sad, because basically any topic has these sentiments to it. For example, mental health can be positive in kind of awareness kind of TikTok content versus, more negative one, which we do see in terms of like maybe cutting or self-harm. So that's kind of like the negative side of it. And we found that, AutoLike can drive the recommendation systems across both dimensions as well. So for example, we choose, sad mental health. We were able to do that compared to the controlled experiment. Another interesting result that we found is that if you do choose a sad topic, like for example, sad cats, the overall, if you look at all the content that is being served, because there are other, content other than sad cats, is that the overall sentiment starts to get sad as well. So the agent started getting TikTok that were sadder nature, not just sad cats. So I thought that was really interesting.
Can you zoom in on the ways in which you used reinforcement learning in the project?
So first, to kind of understand AutoLike, I need to explain at a high level what reinforcement learning means. So reinforcement learning is a type of machine learning where a smart agent is tasked with maximizing its cumulative rewards over time through trial and error. So to do so, the agent interacts with an environment. After every action, the agent receives a feedback in the form of a reward. It takes this reward and learns from it to take better actions in the subsequent steps to earn higher rewards. So for example, if we take a city map where we need to drive from point A to point B in a 2D space, so at each intersection, we need to decide to turn right, left, or go forward, right? After each decision, we get a reward where high rewards reflect that we got closer to our destination. So the challenge here is that the agent, knows nothing about the environment. So it knows nothing about the map, and it has to learn it from scratch. So in the beginning, it may make certain actions into certain turns that may, go farther away from the destination. And second, the agent will have limited tries to interact with the environment. It must choose an action wisely at each step. So for example, let's say there's a limit to how many turns that the car can do to get to a destination. So now the problem gets a lot harder. There's a lot of extensive literature on this, and it has been applied across many different problems, such as, for example, training an RL agent to play a video game, or figuring out which advertisement produces the most clicks and buys from users. In my own work, I've applied RL to generate filter rules automatically to block ads and tracking on the web. And I've also applied reinforcement learning with Roy and Sophie's Sensor Planet lab at the University of Michigan to efficiently learn which internet domains are being censored or blocked across geographic regions. So here, I'm also applying this kind of reinforcement learning framework in AutoLike to audit recommendation systems. Okay, I hope that was a good overview. So now, how does reinforcement learning is used for this particular work? Basically, what we look at is a user first selects a topic of interest. For example, the user wants to drive the recommendation system to serve it cat content. We start from scratch, a very fresh For You page, and it knows nothing about the user. This agent is going to interact with the platform like TikTok, and it's going to try different actions available to it, like liking, bookmarking, sharing, or watching. And it knows nothing about how these actions will drive the recommendation system to serving the cat content yet in the beginning. So it's going to keep watching videos one step at a time. And after each step, it looks at the kind of content that's being recommended. So if it's close to cats, for example, maybe it's pets or dogs, then it will receive a high reward. And that means that it will know for next time that it should, like that type of video.
Well, if I'm not mistaken, AutoLike, although we've described it so far what it does, and I've described it like a proof of concept that indeed it can find problematic content, but it's designed for auditors. Who do you see as the users of the system, and what are they using it for?
Yeah, that's a good question. So we envision users of AutoLike, such as regulators, for example, from the FTC, who want to perhaps capture evidence that a platform is recommending certain types of content in a very, easy to get there manner. For example, if I only need to view 50 videos or interact with it 50 times, and I'm already getting a bunch of problematic content, then that may be an issue. It can also be for the platform designer, right? So they can be like, oh, I think in terms of capturing the kind of content that we don't want, I think we're doing a good job, but okay, let's, apply AutoLike or similar methodology on top, because it treats the platform as a black box, right? It's just using it in an automated fashion. And maybe it does find certain content, or maybe it's very difficult. Maybe it's across thousands of videos before it can find certain problematic content.
Well, as you'd mentioned, the platform is a black box. They don't give you their source code or tell you exactly how their system works. You're maybe guessing based on some papers they've written if those things are even still relevant and all that kind of stuff. So you're never sure what you're interacting with. I guess in one individual trial, maybe that particular user was put into some A/B test and they had a weird experience. But I guess in aggregate, you start to see something. Do you have a sense of like how consistent the user experiences are after running many trials?
I think that's really difficult to answer. Definitely with our work right now, it's kind of a work in progress. And you're right that we do need to do it across hundreds to thousands of more times. And there's other factors to consider, such as the starting profile. Maybe you can make a child account or maybe an adult account, which location you're in, what time you're going to run the experiment, or maybe you can preset certain interests for that profile and then see how it reacts. So all these factors are kind of things that we would have to run more to see how the system reacts. What's nice is that, it is automated, so it will help. And it's something that, for example, these systems will change anyways over time. So we can't always do, manual processing. So for example, maybe we run AutoLike every 6 months or every 3 months, that kind of thing. And that can help try to see how platforms change over time. Now, you actually brought up a very good point in terms of challenges of this type of research, is that when we train the RL agent in real time, meaning we're actually using TikTok, it takes a lot of time because you actually have to, watch the video, for example, and there's also overhead where you have to extract the video and then classify that kind of content over hundreds of thousands, and then multiply that also over hundreds of thousands of videos, multiply that by hundreds of thousands of experiments. That takes a long time. Yeah, so there are ways to kind of reduce that in terms of, for example, if we can simulate the environment, not use real TikTok, but have a similar environment that behaves like TikTok, then it could maybe return that reward quicker. So one way to do that is, for example, get a lot of data from users that have used TikTok, and then kind of use those user data to kind of model a simulated TikTok, basically. And then that way you can completely do it super fast. That is definitely the next step for AutoLike.
So could you talk a little bit about someone who wants to use AutoLike? I don't know if you offer AutoLike as a service or if they can clone a repo and spin it up. How does a person get started?
That's a good question. Unfortunately, I have received requests about using it, but I have not open sourced it at this time because it's a work in progress still right now. But definitely the plan is to open source it as any of the other research that I've done. So, and it would be available on GitHub usually, and perhaps additional data sets of all the TikTok sequences and interactions that we've collected.
And can you talk a little bit about the engineering feat? I think maybe a lot of heavy duty work and coding probably went into this. It's not a simple thing to set up. What did it take to make all these measurements with AutoLike?
So to interact automatically with TikTok, for example, we use a Android phone, and then the Android has a feature called UI Automator, which allows us to kind of extract elements from the screen that we see and then do certain actions to it. For example, extract the screen that we see, look for the like button and then click it, or look for the share button and then click it. And then that's how we kind of simulate those user interactions. And then we, like I said, we would extract the TikTok URL, we send it to our external server, and through there we would use, Selenium. It's a Python framework that can control browser to go to that TikTok, download the TikTok, and then extract all the information needed to classify the TikTok as whether it's on topic or not, or whether it's sad or happy.
Very neat. And could you maybe give some broad level thoughts on, I guess, like the throughput or scaling this up? If you had a massive auditing effort you wanted to undertake, measuring lots of topics and categories, what would it take to get that going?
Yeah, doing it in real time, that's very difficult to scale. That means that you would have to have maybe tens to hundreds of Android devices and a server that can handle all the processing, all the downloading of the videos, and also, doing zero-shot classification of all those videos to get those scores for what type of content that we're looking at. So this is why we are looking to the next steps of how do you train the RL agent without actually going to TikTok. And that way we can actually scale it much higher. And then once you train it, you can just apply it to TikTok and have it do what it does.
So if an auditor then takes on a project using AutoLike, they have a goal in mind. We've described a lot of, I guess, the raw data they could get. You could probably share details about the policy the agent developed and the types of content it saw and compare those to the baseline, always swipe away strategy you described. But how do you envision someone formalizing that into a deliverable? I would imagine a policy person wants to either go in front of a committee or write a report or something like that. What is the key takeaways that they'll get from the effort to inform whatever decision they're looking to make?
Yeah, so the output of AutoLike is basically just going to be a sequence of interactions and TikTok videos, right? This is only taking TikTok as an example. From there, what people can do is they can look at how quickly it took to get to a certain type of content. They can say, oh, wow, it's very easy to get to, negative or problematic content, or it's just as easy to get to cats videos as self-harm videos, something like that. We can also look at the types of content that we were able to see within the one run of AutoLike, for example. You can also characterize that and say like, wow, this platform says that it should not have this kind of problematic content, but we were able to find tens to hundreds of it. It spans these topics. Maybe there's very obvious hashtags that are on these things. Maybe they can also say it's very difficult to find because there's no hashtags or the special hashtags.
There's probably no sense in which a platform could say we have zero problematic content or 0%. They're really just looking to minimize on that. Or maybe the world looks at it differently and I'm not close enough to the problem to understand. Let's say we want to give a report card to every social media platform for the quality with which they've made it difficult to access problematic content. Are we in a place where that's even a well-posed question?
I think you're asking, how easy is it to audit these platforms? Is that what you're saying?
Yeah, like if, let's say we decided we wanted to give a report card to everybody. Maybe they all get A's, maybe they're all failing. Do we even know what we're measuring?
I think that's a good question. I mean, there's so many factors that you can look at. For example, AutoLike really just looks at the particular interactions and the content as a result. So that's what the output is, right? But there's other factors that people can look at. For example, how does it impact the actual users? How do the users feel when they use these platforms? Is it addicting? Is it positive? Are they having fun? How is the content affecting them? And more recently, people are looking at the kind of addictive features that are being deployed on these particular platforms as well. So I think it really just depends on what the report card wants. I mean, maybe they could do like, oh, this is very addicting, or this is very bad for kids, or I'm not sure. I mean, maybe these things are okay as well with limited time usage. Some of these platforms have, for example, like TikTok used to have a feed that's just about STEM, or imagine some educational For You page only. Is that still good for the user if they're able to, use it nonstop? Is that still addicting or harmful? No, I'm not sure. So yeah, as a society, we're still kind of figuring out these potential harms or potential benefits.
Do you think it's going to be psychologists or computer scientists who figure out how we measure and hopefully mitigate these biases?
I mean, definitely as a computer scientist, we're able to develop, frameworks and tools to get data that can be helpful in characterizing these problems, but we don't really have the expertise to understand how do users feel, that kind of.
I know you've now been pretty close to TikTok, and maybe you've looked at other platforms as well in trying to get data out of that black box. And AutoLike is a project that accomplishes that pretty well. What if there was a world in which these platforms were a little bit more cooperative, especially for researchers? If you had a wish list or something that you think they would be willing to do that would be beneficial, do you have any ideas on what that might be?
Yeah, that's a great question. Yeah, definitely. If the platforms are able to provide, special environments or APIs that researchers can hook into. For example, if I give an ID of a particular video content, if they can just give me back the type of content it thinks it is already, then that would be very helpful, right? Or maybe even providing data sets on the platform's usage would also be helpful. And maybe with where the data sets are anonymized for research use.
And what about the future of the project? Where do you see AutoLike going?
The future of AutoLike first is that we're trying to scale, the evaluation of the tool, which means that we need to find more data usage so that we can kind of model the platform in a similar manner, so we can run more controlled experiments without actually going to the platform or going to TikTok, which would take a long time. And then also, we can definitely, apply this to all the other platforms as well that has For You pages. It's kind of the same thing. And our implementation is kind of agnostic of the app because it's using UI Automator, which is just simply interacting with an app. It doesn't necessarily need to be TikTok. AutoLike is actually agnostic of the dimensions that I spoke about. Like, for example, we looked at topics of interest and sentiment, happy or sad, but really people can look at any other dimensions that are important to them as well. For example, maybe people care about whether the content is misleading or not, or any other factors, really.
We talked a little bit about what's next for AutoLike. What's next for you?
Yeah, thank you for asking. So in May of this year, I will be presenting my work, SenRL, a framework for performing intelligent censorship measurements, with Ram, Raman, and Roy and Safi at the IEEE Symposium on Security and Privacy. In July of this year, I'm also co-chairing the Policy Relevant Privacy Workshop, which is co-located with the Privacy Enhancing Technology Symposium. So this workshop brings together researchers from computer science, law, and public policy, along with practitioners, to explore how research can better inform privacy regulation and enforcement, and vice versa.
And is there anywhere listeners can follow you online or find out about that symposium as well?
Yeah, I have a website called liveonhue.com that I usually post all of my work and also all the upcoming events that I'll be attending as well. So please check it out.
Very good. We'll have some links in the show notes for listeners to follow up. Well, thank you so much for taking the time to come on and share your work.
Thank you so much. It was a pleasure.